Okay, so we had just we pretty much finished correlation in class, but we just had a little bit, a few examples to go with kind of partial autocorrelation. So just to kind of recap, partial correlation is this situation where you have a correlation between two variables. So in this case, we've got a correlation between how well we do in the exam and anxiety about the exam. I would assume that this is negative. As you get more anxious, your exam performance would go down. But there's a third variable here, revision, which actually affects both of the other two variables. If I revise more, I'm going to do better at the exam. And if I revise more, I probably have less anxiety. So what we can do is we may want to find the relationship between exam and anxiety, accounting for the fact for revision and kind of removing the effect of revision from this equation. And we also define semi-partial correlation. And here we assume that revision affects the exam result, but it doesn't actually affect the anxiety. So we could either have revision affecting the exam or anxiety, or in the case of partial correlation, potentially both. So let's just kind of work out how we do partial correlation in SPSS. So let me go to, this is the IHNO data set. Now to do partial correlations, we're just going to do analyze, correlate. Now before in the class we used bivariate, this time we're going to do partial. And so what we want is, let's just think about this example again. We're interested in the correlation between the heart rate and your score in the exam. So we're using the heart rate kind of as a measure of, anxiety. So we think that, people who are doing badly on the quiz are going to have their heart rate suddenly increase. But we also talked about, when we've done this data set before, how some people have naturally high heart rates and some people have naturally low heart rates. So this is going to kind of muddy the correlation between the heart rate after the exam and the quiz, because it's not accounting for the fact that some people have high heart rates and some people have low heart rates. So let's just kind of do a partial correlation and look at the heart rate before the quiz to see, to get the effect of the heart rate change during the quiz. So we're going to keep a window two-tailed test of significance, and we're going to display the significance value. And here, this table is exactly the same as the non-partial correlation. We just have a table of the variables we're correlating, but this time we're accounting for the control variable. So here we can see that the correlation is actually pretty low. So the correlation between, I remember this is symmetric, so the bottom left is the same as the top right, but the correlation between heart rate post and math quiz accounting for heart rate pre is 0.068, and the significance on the test that the correlation, where the null hypothesis is the correlation equals 0, alternative hypothesis the correlation is not equal to 0, as you can see it's a very, very non-significant. So that's partial correlation in SPSS. So let's just kind of have a look at the actual equations here. And if we look here, we have the correlation, the partial correlation. So the partial correlation between two variables. So imagine that this is between the heart rate post and the exam score, accounting for a third variable, which in our case would be heart rate pre. It's basically the correlation of the two variables minus the product of the correlation of each of the variables and the third control variable. And then we just normalize by the correlations for the third. This is just a normalized factor at the bottom, the correlation with the third variable. And the semi-partial correlations are almost identically the same, but we kind of miss out one of the normalizing factors. So between A and B, accounting for C, where C only operates on A, we just have the normalizing factor for the correlation between A and C, and the same for B. Now, don't worry, I don't think I've ever set a partial correlation a semi-partial correlation question in an exam. This really is, once you get into your other future courses, you're going to be looking at concepts like moderation and mediation, where you've got relationships between variables and you've potentially got a third variable influencing or affecting this variable. So partial correlation is like almost an intro to that topic. But you're going to be looking at this more. I think it will be in maybe in the spring semester or maybe in Dr. Lander's kind of experimentation class and survey class. So here's a little example which I've actually done in Excel. So we have basically an Excel sheet here, and we have car production, car sales for domestic and imports from 1990 to 2010. And you can see the sales of domestics and the sales of imported cars. And you can see we actually calculate the correlation between these two values. Now, unsurprisingly, there's actually a negative correlation here because, when domestic goes up, imports goes down and vice versa. How well domestic manufacturers are doing relative to foreign manufacturers. If the dollar becomes I teach about this stuff in my international marketing class. If the dollar becomes very strong, it makes the US manufacturers less competitive and you get more imports, the dollar weakens, and then the opposite happens. Anyway, this is not an international trade class. But this relationship is almost moderated by we have the population of the US, because the cars are kind of increasing over time, and this is kind of like affected almost by the population. So it might not be a strong variable. This is just an example of a third variable that could affect the relationship between domestic and imports. So we actually have a partial correlation, which is the correlation between domestic and imports minus the correlation domestic times population times imports times population divided by those two normalizing factors. And this actually lowers the correlation between the negative correlation between domestic and imports substantially. And rather than being minus 0.44, it's minus 0.209. And let's just kind of go back, our final slide. We just kind of summarize this correlation. So we have the correlation between domestic and imports, subtract, and there's actually the correlation between domestic and population, which is kind of negative. And I think this is because, domestic, as the population has increased of the US, domestic production has fallen as imports become a little bit higher. So there's maybe even a third factor at play here. And we also have the correlation between imports and population. As the population has got higher as time has moved on, we have this positive correlation. So it's this value minus those two correlations. And then we normalize by the domestic and population correlation and the imports and population correlation. Okay, so that's just the little few things that I wanted to finish off on correlation, and we'll move on to linear regression.